Okay, now we will do 3 more examples of the AC method. If you feel ready, pause the video and do this one on your own. Or at least make a start. Okay, so the way that we'd start this one is I want AC in the top of that little grid. A is 6, C is -3, so -18 goes right there. I put B down below, and that's 7. Now I want two numbers that I multiply to get -18, but that I would add to give me 7. You can either just kind of think about it, or you could list all the factors of -18 and then go through that list until you found one that adds to 7. I will list all the factors for these beginning problems like I did last time, but pretty soon we'll just be able to kind of think about it and find out what those numbers are. But when in doubt, you can always just list the factors of AC. So 1 and 18 aren't going to work no matter what the signs are. 2 and -9, that would give me -7, so I'm close. So it must be -2 and 9. That one right there gives me 7. So I put -2 on one side and 9 on the other. It doesn't matter the order again. I could easily switch them around. That tells me how to split my middle term. So instead of 6n squared plus 7n, I'll write 6n squared minus 2n plus 9n minus 3. Notice that I have not changed the polynomial at all. -2n plus 9n, that's still 7n. I've just changed the form that it takes. Now that I have 4 terms, I group. What do the first two have in common? They both have a 2n. I'll pull that out. The last two have a 3. So if I pull 2n out of the first pair, first term leaves me with 3n. What does the last one leave me with? Don't forget your ones. Those ones are very important. Remember, if you multiply back through and you didn't have that one there, it wouldn't check. But if I multiply back through right now, 2n times 3n does give me 6n squared, and 2n times -1 does give me -2n. Now I factor out the 3, I'm left with 3n minus 1. If I check that one quickly, that also checks. My grouping worked because my binomials match. If they don't match, you can't keep going. So I pull that common 3n minus 1 out front and put my leftovers, my 2n and my 3 in the second set of parentheses, and I'm done. Best way to check that is just FOIL it and make sure you come back to 6n squared plus 7n minus 3. Okay, our next example, so here's our check, and that does check. Next example, 8x squared minus 6x minus 9. Here's my diamond, or my grid, whatever you want to think of it. Okay, A times C, 8 times -9, that's -72. My B is -6. What two numbers multiply to give me -72 and add to give me -6? There's the whole big list of them, all the factors of -72. Again, that's probably overkill to list them all, but if you're not seeing it right off, it's not a bad idea to list them. Okay, so if we went through, we said, okay, to find all the possibilities, we list our factors of AC, and then we'd find what they add to, and 6 plus -12 gives me the -6. So let's just check this in the diamond. 6 times -12 is -72. 6 plus -12 gives me -6. That tells me how to split my middle term. So 8x squared minus 6x minus 9, I'll change that to 8x squared plus 6x minus 12x minus 9. Notice that if I were to recombine those middle terms, I would get -6x. I have not changed the polynomial. I've just tweaked it a little bit. Now if we do our grouping, what do the first two terms have in common? They both have a 2, they both have an x. Let's pull out that 2x. The last two have a 3 in common. Why did I pull out a -3? I pulled out a -3 because the last pair has a leading negative. Whenever you have a leading negative, you need to pull out the negative. Okay, so I pulled 2x out of the first pair. I'm left with 4x plus 3. Pull negative 3 out of the second pair. I'm left with 4x plus 3. Take a second to double check your work. 2x times 4x? Yes, that's 8x squared. 2x times positive 3? Yes, that's positive 6x. Negative 3 times 4x? Yep, that's negative 12x. And negative 3 times positive 3 does give me negative 9. Okay, 4x plus 3 is common. My leftovers are 2x minus 3. And I can check it by using FOIL, and I do get the polynomial I started with. Okay, one more example using the AC method, and then we'll go on to diamond. 4y squared minus 2y plus 2. Now I've been a little bit lazy about making sure that we did something at the very beginning. What are we always supposed to look for? We're always supposed to factor out the greatest common factor. Each of those terms had a 2, so I want to factor out the 2, and I'm left with 2y squared minus y plus 1. Okay, my AC is 2, my B is negative 1. What two numbers could I multiply to get 2 and add to get negative 1? Well, these are my only choices, 1 times 2 and negative 1 times negative 2. But neither of those work. So what do I put here and here? Remember, if you've tried every possible choice and none of them work, you have a prime polynomial. So the only way that factors is by taking out the greatest common factor.